everyone. Welcome to ninth class. I'm going to solve this example. Then we'll proceed to consider vector. Yeah. Good evening. How are you guys? You're welcome to ninth. Tonight I'll be talking about vector. And let us proceed. Let's proceed. It's okay. So since there's no question, it means let us multiply out. Minus 1 times 1 is minus 1. Minus 1 times I minus I. Then plus I times 3 is 3I. I times minus I is minus I squared. Plus minus I times 2 minus 2I. That times plus is minus 2I minus I times plus I minus I squared. Amen. Then this is minus 1 minus I plus 3I. Amen. Then I squared is minus 1 minus open bracket minus 1 minus 2I minus open bracket minus 1. So here will now be minus 1 minus I plus 3I. Minus 1 times minus 1 plus 1. Minus times minus plus. So plus 1 minus 2I. Then minus times minus plus 1. Amen. Plus 1. So let's collect the like terms. That is to position the real, separate the real and the imaginary part. Is that clear? So here we have minus 1. Program right. Wait. I raised to the powers of this is what? Oh, this is sorry. There's a mistake here. I times this is I minus I. Sorry. So it means there is a mistake here. Sorry. Please sorry about that. I discovered the mistake here. Very sorry about that. It's okay. Here is minus I, right? Please, I'm very sorry about that. I noticed mistake there. Okay, so here supposed to be, this is minus I. So when you multiply, you are going to have minus I times 1 minus I times plus I minus I squared plus I times 3 is 3I. I times minus I squared. Then plus times minus, so minus I times 2 minus 2I. Then minus times plus is minus I times I minus I squared. Amen. Okay, so if you agree with me, let's go back. I squared is minus 1, so minus I minus open bracket minus 1 plus 3I minus I squared. Amen. Minus I squared minus 2 open brackets, minus 2I. Here we are supposed to write I squared is minus 1, right? Minus 2I minus I squared is minus 1, right? Okay, so far so good. Here is minus I, minus times minus, plus 1, plus 3I, minus times minus, plus 1. Then here is minus 2I, minus times minus is plus 1. Amen? So here we collect like terms, that is taking the real and the imaginary parts to the respective parts. So here we have 1 plus 1 plus 1. Amen? Then we have here minus I plus 3I minus 2I. So when you look at it, this will go, two of us. So we'll be left with 1 plus 1, 2 plus 1, 3. This is the answer. Do you have any question, please? Any question? Do you have any question? Yes or no? No question. So it means we can proceed. No question? No question. It's okay. There's no question, right? There's no question. Let's proceed. Let us proceed. No question, right? Please, I want you to like and comment. So let's proceed. There's no question. I want us to proceed further. Let us proceed. Let's proceed to consider vectors. Yeah. When we say vector, vector is a quantity that has both magnitude and direction. Is that clear? Vector. Is a quantity that has both what? Magnitude and direction. Example, force. Examples of vectors. Examples are force, velocity, acceleration, etc. That is vector. Yeah. And vector can be written in capital letter or arrow, small letter. But sometimes you can have it in this form. Yeah. This is also known as what? A vector. Is that clear? So whenever you come across this or this, we call it what? A vector, because we can have a vector of this form. If we have this I plus j plus k, this is a vector. Is that clear? Any question? Yes or no? So when you come across something of this form, it is known as what? A vector. So now let's proceed to define what scalar quantity is all about. Is that clear? Scalar quantity vector quantity is vector quantity, scalar quantity, okay, amen, amen, is a quantity that has only magnitudes but no direction. Yeah. Scalar quantity is a quantity that has only magnitudes but no direction. E.g., speed, yeah, displacement, time, mass, etc. Is that clear? Etc. So this is a scalar quantity and examples of scalar quantity. Is that clear? So take note. Amen. So far, so good. So now I want us to go deeply to know, understand how these things, both vector quantity and scalar quantity, is applied. But before that, we are going to consider what is called magnitudes or modulus or absolute value or norms. How we are going to find this. Amen. So let's look at it together. Let's look at it together. That is magnitude. How to magnitude is always represented in this form. It's either a or small letter a vector. So this is a magnitude, or it is also called absolute value. Absolute value. Is that clear? Or it is also known as norm. But the norm is in this form. Yeah. Is that clear? So if we are to find this or this is always in this form: x squared plus y squared plus z squared. Amen. Likewise, this is also x squared plus y squared plus z squared. Right? Are you following? Okay. So that is that. So far, so good. So let us go ahead to consider some examples how we can find the magnitudes of any given vector. Any given vector Amen. Okay, so let's look at an example. Given vector A, but before we consider this, given a vector okay, let's say if a vector A is equals to 3I plus j plus k, find the magnitude of A. Yeah, you may likely see questions of this one, but I think before we proceed further, I want to say something. Sometimes we can leave vector, write vector in this form. This is also a vector. We can write it in this form. It means if we want to interpret it, it means our vector A is I plus 3j plus 2k. Is that clear? Are you following? You are following, right? Okay. So far, so good. Amen. Okay. So let's look at the absolute value of, magnitude. Find the magnitude of A. So if now I want to find the magnitude of A, this implies that our vector A is equals to 3I plus j plus k, right? So magnitude of vector A will now be equals to, this is in geometry, when we have y, x, we call it what? Two coordinates geometry, true or false? Then by the time we now have z, this is three coordinate geometry. Three coordinate system, sorry. So it means this is our x, this is y, and this is z. Is that clear? So this implies that square root of x squared plus y squared plus z squared. Amen? So our x is 3. So 3 squared plus y is 1 because 1j. This is 1 square. Z is k, 1k. This is 1, which is 1 square. Please don't ever write the square root in this form. Some of you are fond of this, writing it in this form. It means this square root affects only this 3 raised to power 2. So you write it in full. Is that clear? Take note. Okay, so our vector A, that is magnitude of A, when we say 3 square, 3 square is the same as 3 times 3, which is what? 9. Here is 9, 1 times 1, 1 plus 1. This is equals to 11, right? So this is how to find magnitude or absolute value or norms of a given vector. Do you have any question? Do you have any question? Please drop it in the comment section. Any question? No question. It's okay. So let's proceed further to consider how we can obtain angle between two vectors. Is that clear? How we can obtain angles between two vectors. How we can obtain angles between two vectors. How to obtain angle between two vectors. Amen. Okay, yeah. So how can we obtain two vectors? Given two vectors, that is A is equals to 1, 2, and B equals to 2 minus 1 and 4. Find the angle between the two vectors A and B. Amen. Let's look at it together. It is simple as ABC. It is not difficult. So far, so good. So what we need to do here is, if we want to find angle between two vectors, is as simple as ABC. Our cos theta is equals to vector A dot vector B, then all over magnitude of A times magnitude of vector B. So for us to find the angle, it means our theta will now be cos inverse of this vector A dot B all over magnitude of A and magnitude of B. Amen. Okay, so if you agree with me, it means at first we are going to find the magnitude of what? A. So of course, so magnitude of A is equals to look at it, 1, 2, 3. So x is 1 square plus y is 2 square plus 3, z is 3, Then this is equals to, this is equals to 1 plus 2 plus, 4. Here is 4 plus 9, 10, 14. Our magnitude of A is equals to 14, right? Right? Okay. Then let's obtain B. The magnitude of B is equals to this. That is x is 2 square plus 1 square minus 1 square plus 4 square, which is equals to square root of what? 4 plus 1 plus 16, right? Am I right? Am I right? So this is 21, true or false? So magnitude of B will be equals to square root of 21. 4 plus 16, 20 plus 1. I hope I'm right. Any question, please? I'm just trying to show us how we can obtain angle between two vectors. So as you can see now, let us consider this. Let's consider this. As you can see now, here, dot product. We are going to apply dot product. So it means that is scalar. So it means A dot vector A dot B is equals to I plus 2j plus 3k, open bracket, close bracket, dot open bracket, dot 2I minus j plus 4k. Amen. So I want us to understand one thing. As long as we are applying scalar product or dot product here, note that I dot I is always 1, then I dot j is 0, then I dot k is 0. Likewise, j dot j is 1, then j dot I is 0, and j dot k is 0. Also, k dot I is 0. K dot k is 1. Then k dot I is 0, and k dot j is 0. Yeah. So if you agree with me, that this implies that I dot I will give us what? 1 times 2. So our A dot B will now be equals to 2. Then 2j dot minus j is minus 2. Then j dot 4k is plus 12. So you can now see that our A dot B is equals to 12. So it means this will now be equals to 12 all over. Okay. Okay, let's use this space, the formula. This is equals to cos inverse of 12 all over magnitude of A is square root of 14 times square root of 21, right? Yeah. Do you agree with me? Okay, so far so good. I can claim this, right? So the other part, it means our theta is equals to cos inverse, open bracket, 12 all over square root of 14 times square root of 21. Yeah. So your assignment is, I want you to use calculator to solve this and get the angle. Thank you. Any question? Do you have any question? No question? Okay. Thank you and God bless you. I wish you a wonderful bed rest. Love you guys. Bye. Yeah.
Don't finish to be on it.